back. The last three videos we've talked about lines, linear equations, or linear functions, and we talked about the three different forms that lines can be written in. We had slope-intercept form, y equals mx plus b. We had point-slope form, where you have a point in the slope and you can find the equation, y minus y1 equals m times the quantity x minus x1. Then we had standard form, which is great for x and y intercepts, ax plus by equals c. We're going to wrap up talking about lines by talking about parallel and perpendicular lines. Now, you probably know this. Parallel lines are lines that run such that they never actually cross each other. So they're running at the same slope. You're going to learn about that. Perpendicular lines form 90 degrees, or like x's, or plus signs. And they run at inverse reciprocal slopes. Okay? So in order to see if two lines are parallel, we're going to start with parallel lines. You have to make sure to write them in slope-intercept form. We want to get them in slope-intercept form to know whether or not they're parallel. Okay? Parallel lines have slopes that are the same. Okay? Parallel lines have slopes that are the same. So for example, y equals 3x plus 4 and y equals 3x minus 9 are parallel because in both cases m equals 3, right? M equals 3, and then they have different y-intercepts. All right, so that's pretty simple, right? Parallel lines have the same slope. That makes sense. I'm just going to draw a little graph to show you what it would look like, right? So y equals 3x plus 4 would be something like this. And y equals 3x minus 9 would be something like this. Okay? So they'd be running parallel to each other. They would never touch. So let's see how we can use this information. It says writing lines that are parallel to given lines. Okay? So example 1 says write an equation in slope-intercept form, what we're looking for y equals mx plus b, of a line that passes through the given point and is parallel to the graph of the given equation. Ooh. Okay, so we have a point 3, 5. This point 3, 5 is going to be on the line that we're looking for. Okay? And then this y equals 2x plus 1 is a parallel line. Okay? Parallel line. So what do we need to do? Step 1, identify the slope of the given line. Okay, well, what's the slope here? That's not hard, right? We can see very easily that the slope is 2. So m equals 2 over 1. 2. Okay? If that's the case, then we know that the line parallel has to have the same slope. M equals 2 over 1. I can just say this is 2. Right. We have to identify the point that we're on. We're given that. That's 3, 5. So now we have a slope, m equals 2. We have a point, 3, 5. That's pretty easy. We just use point-slope form. Y minus y1 equals m times x minus x1. Y minus y1, our point is 3, 5, so y minus 5, equals m is 2, times x minus x1, which is 3. Okay? Now, here's where it gets a little bit tricky. We got to convert it to slope-intercept form, because if you remember up here, it says write an equation in slope-intercept form. This is in point-slope form. So we got to convert. To do that, we just have to distribute them, then move the constant to the correct side. Just solving for y, right? Because we want y equals mx plus b. So y minus 5 equals 2 times x minus 3. I'm going to distribute. Y minus 5 equals 2x minus 6. Okay, then I'm going to add 5. Add 5. I get y equals 2x minus 1. That, my friends, is our equation for a parallel line. Okay? Let's move on and look at a couple more examples. So here, sorry about that, it says write an equation in slope-intercept form, we're still at y equals mx plus b, of a line that passes through the given point and is parallel to the graph of the given equation. Okay? Let's go through these steps. First of all, we know that 4, 6 is going to be on the line, and we know it's going to be parallel, so that means our slope has to be the same. The slope here is m equals negative 1/2, so that's going to be our slope. So now we have a point and we have our slope, right? Okay, well let's just plug that into point-slope form. Y minus y1 equals m times x minus x1. You're going to get a lot of practice with this. Y minus y1 is 6 equals m, negative 1/2, times x minus x1, which is 4. Okay, we're going to distribute. Y minus 6 equals negative 1/2 x right? Negative 1/2 times x is 1/2 x. Now, negative 1/2 times negative 4, sorry if you can see that over my thumb, negative 1/2 times negative 4 is positive 2, plus 2. I'm going to add 6 to both sides. I get y equals negative 1/2 x plus 8. This is the equation of a line that is parallel to y equals negative 1/2 x plus 3 and passes through 4, 6. Let's do one following one. It says write an equation, sorry about the S, blame escape-pack. Write an equation in slope-intercept form of a line that passes through the given point and is parallel to the graph of the given equation. Ooh. This is going to get a little bit tricky because I see a point, negative 2, 3, that's easy. But how do we find the slope here? Well, this is in standard form. Remember standard form, ax plus by equals c? That's better for graphing with intercepts, finding intercepts, not great for finding slope. So we have to convert, it says hint, first convert to slope-intercept form, which basically means solve for y. So I've got 2x plus 3y equals 6. I'm going to subtract 2x from both sides. I'm going to have 3y equals, I'm going to put the 2x here because we're used to that form, x plus b, all right, mx plus b, plus 6. Then I'm going to divide by 3. But I got to do that everywhere. So y equals negative 2/3 x plus 2. 6 divided by 3 is 2. Okay? Now we have our line. So we can find that our slope m equals negative 2/3. Right? Okay, so now we have m equals negative 2/3. Our point from up here, I can see that, is negative 2, 3. So let's plug that in. Y minus y1 equals m times x minus x1. So y minus 3 equals negative 2/3 times x minus negative 2, all right? Minus negative 2, which is the same as plus 2. Distribute. Y minus 3 equals negative 2/3 x minus 2/3 times 2 is 4/3. Okay? So we get something that looks like that. We're going to add 3 to both sides. We get y equals negative 2/3 x. Now, 3 is the same as 9/3, right? So we have negative 4/3 plus 9/3, which is going to give us 5/3. So that is how to find equations of lines that are parallel to a given line, right, and run through a given point. Parallel lines have the same slope. Guess what? Now let's talk about perpendicular lines. Perpendicular lines. So if parallel lines have look like they're never going to touch, or actually I should say look like they're never going to touch. These literally are perpendicular lines, but I'll draw some new ones using a different color. These would be perpendicular lines. This is a right angle, okay? 90-degree angle. So in order to see if two lines are perpendicular, we need to make sure to write them in slope-intercept form, and then we have to compare their slopes, right? Compare their slopes. So perpendicular lines have slopes that are opposite reciprocals. Opposite reciprocals, okay? So what does that mean? That means if m equals x, then a perpendicular line is going to be m equals negative 1 over x. Reciprocal is 1 over x. It's a negative of that. Okay? So, for example, here we have y equals 1/2 x plus 3. Here we have y equals negative 2x. The reciprocal of 1/2 is negative 2. So these are perpendicular. Okay? So let's see how this plays out, just like we did with our parallel lines. Example 1 says, write an equation in slope-intercept form of a line that passes through the given point and is perpendicular to the graph of the given equation. 3, 5 is our point. Y equals 1/3 x minus 4 is our line. So the slope of the original line, right here, is m equals 1/3. Well, we need to find the slope of the perpendicular, so we need to find the opposite reciprocal. Okay, so m equals negative 3. 1/3, reciprocal is 3, positive, so it's going to become negative. Great. Now we're cooking. Identify the point. The point is 3, 5. Let's use point-slope form. Y minus y1 equals m times x minus x1. So y minus 5 equals negative 3 times x minus 3. Then we just have to convert it to slope-intercept form. We distribute them, the slope, then move the constant to the correct side. So y minus 5 equals negative 3, x minus 3. Distribute 1, 2. We get y minus 5 equals negative 3 times x, or negative 3x. Negative 3 times negative 3, which is positive 9. Add 5 to both sides. We get y equals negative 3x plus 14. It's that simple. Whoop, you can't quite see that. I apologize. So perpendicular lines, opposite reciprocals. I know I'm moving through this pretty quickly, but at this point, most of the manipulating line stuff is all review, so I'm hoping that it's just a matter of you seeing how we will find the slope of either the parallel or, now in this case, the perpendicular line. Okay, so last two examples. Example 2 says, write an equation, slope-intercept form of a line that passes through the given points perpendicular to the graph of the given equation. Okay, so this is our point, 1, 4. Our equation is y equals 5x plus 2, so that means m equals 5 here. So for our perpendicular line, okay, our slope is going to be negative 1/5, opposite reciprocal. Cool. Y minus y1 equals m times x minus x1. Y minus 4, right, we got 4 from up here, equals negative 1/5 x minus, what's x? 1. Distribute. Y minus 4 equals negative 1/5 x plus 1/5. Add 4. Y equals negative 1/5 x plus 4 1/5, which is also 21/5. Okay, and then one final one that we're going to work through together. Example 3, write an equation in slope-intercept form of a line that passes through the given point, perpendicular to the graph of the given equation. We get 1, negative 6, and we have x minus 2y equals 4. Once again, we're stuck back here in standard form. Standard form, ax plus by equals c. We need to put this into slope-intercept form, right? Y equals mx plus b, so we can find out. So we have x minus 2y equals 4. We're going to solve for y, so I'm subtracting x from both sides. I get negative 2y equals negative x plus 4. Divide by negative 2, across the board. And I get y equals negative x divided by negative 2 is positive 1/2 x. 4 divided by negative 2 is minus 2. So here is our equation of this exact line in slope-intercept form. That means m equals 1/2 is our slope. For our perpendicular line, if m equals 1/2 here, that means that m is going to equal negative 2, opposite reciprocal. All right, y minus y1 equals m times x minus x1. Y minus y1, negative 6, so that means it'll be y plus 6, equals m, which is negative 2, times x minus 1. Okay? Solve for y. Actually, let's distribute first. Y plus 6 equals negative 2x plus 2. Subtract 6. Y equals negative 2x minus 4. That is a line that is perpendicular to x minus 2y equals 4 and goes through 1, negative 6. Whew, that was a lot. I went through that very fast. I apologize, but I wanted to make sure you could see it. And I feel like you've had enough practice manipulating equations at this point of lines that it should be pretty straightforward after you find the slope. Remember, parallel lines, same slope, perpendicular lines, opposite reciprocals.